Good morning, one and all. My name is Dr. B. Srinivasu, Department of Mechanical Engineering. Today we are going to discuss about the laser beam machining. Okay, that is also one concept from the our third unit of a from the modern machining and the forming method. Okay, so now from the see here from the laser beam machining. Okay, from the third unit. Okay, so the term of a laser. See, already we have discussed in our welding, means in a solid state of a welding, we have already discussed about the what is the meaning of a laser beam of a welding process. Now we are discussing about the with the help of laser beam of a machining. Laser, by using of a laser with the concept of a beam, we are removing the excess of material. That is the machining means metal removal rate here. Okay. So here, if I say something, what is the meaning of laser? Already we have discussed from your previous of a means of a class when you're in second year. Okay. So here, the what is the meaning of laser? Is a light amplification stimulated emission radiation. With that of a laser, now we are going with the high beam. Means what happened? We are with a high beam metal removal rate can be taken place here. Means in which way? We know the concept of a the laser of a once again I am repeating, the laser is light amplification simulated emission radiation here. So what is going on here means with the electric energy is converted into a light energy. Means here what is going on here, the electric energy will convert into a light energy, then this energy is converted into a heat energy. Got the concept? Means electric energy, because we have everything is a power supply of this one. Okay, so we are saying of a this of a ruby crystal is taken place, already we know that from the laser. Okay, so here we are converting of a electric energy, we will convert it to a light energy, then this light energy is converted into a heat energy here. So what happens, this means of a radiations will be formed here with this of a light amplification. What happened, the radiation which is from the ruby crystals and the this focus, what happened, this falls on the focus focal length, and then it is a falls on the material, and the excess of material can be removed from the workpiece. This is the basic concept of our laser beam of a machining here. Okay, so clear. See from the our diagram, we can say this is a okay. This is how the power supply can be carried out here. Okay, how the power supply can be carried out here. After that, the flash lamp, then the reflecting end, the laser of a crystal we are using. It may be a crystal, it may be a ruby crystal. We can say here solid state. We can go with that one, or we can go with the gases of a state. So there is a partially of a reflected of a and can be taken place here. This is a and this is a lens here. Focus of a lens we are saying of a the radiation which is a which is falling on this is a this red color is a radiations. Okay, so emitting of this one. Okay, which is falls on the workpiece. So it will be a means of a n number of radiations is falling. So it will be a, make it a single point here. Where due to with the help of a lens, focus lens we can say here. Okay, so this is a basic of our principle here. See, we can go with the see this one of a how the basic concept of a here the laser how can be total setup is taken place here, how the from inside there will be a laser will be formed and the metal removal can be taken place here. Okay, this is very basic principles here. Okay, now see here we are already we know that the laser beam machining is a non-traditional, means unconventional of a machining process we are saying here. So which is a direct towards of a workpiece for machining here, and the process which I'm saying of a here. Okay, means here this process is useful for the thermal. Okay, thermal energy to remove the material from the metallic or non-metallic. Just now I said of a thermal energy. In which way it goes with the thermal energy means just now I said which converts of electric energy will convert into a light energy. That's the reason we are saying of a this process is uses of a thermal energy to remove the material from the metallic or non-metallic of a surface. And here the laser is focused onto the surface to be worked, and the thermal energy of a laser is transferred to the surface. Just now I said of a from the red color, see from this one of a okay. So here what happens? There will be having a this is okay. So this will be having a see. There will be having a laser is a focus on the surface of the work, and thermal energy of a laser is transferred to the surface and heating, melting, and vaporizing the material in this way. Means radiation. Means that is the reason light amplification stimulated emission radiation we are saying. That is the laser. Okay, and the laser beam of a machining is the best suited for the especially for keep in mind sometimes they will ask in a gate question also in which way the laser beam machining is take place, especially which type of a material it will be. So maximum of a brittle material with a low conductivity but can be used on a most of the material here. So it is a most of the thing this of a laser beam of a machining is mainly take place in a brittle material here. Okay, with a low carbon, low conductivity here. Okay, clear. Now comes from the see here. So here the general application. If I'm saying here, okay, if I'm saying of a general applications here. So how the general applications can be carried out here? See, by the general applications of a laser in a manufacture, it may be applications and laser type. It may be cutting, drilling, marking, surface treatment here. So there will be applications of a lay applications and the laser type. Okay. So here the basic principles here. Okay. If I am saying of a applications means of a metals, plastic, ceramic. Just now I said of a laser type, it may be a PCO2, CO, CWO, CO2, means of a neodymium. At the ruby, we are saying of a ruby crystal we are using here. Laser type. See from this one, okay. So here what happened? We are going for the ruby type here. See, this is from the ND. Yeah, is a neodymium here, and a P means of a pulse, and see a continuous wave here, and the yttrium is aluminum of a garret here. So these are the laser type we are using. Depend upon the drilling, cutting, marking here, and we know this one. With the help of this one, we can go with the different type of a laser of a type. We can go with this one. That is the beauty of this one. Okay. Means by using of a laser beam of a machining, we can remove the excess of material from the workpiece. But that is the reason it is comes in a non-traditional of a machining process also. Okay. Now coming to the see here, the working principle, the basic point here. So here, the what is the going on of a working principle? See here, very easy method here. So now see here from the laser, what happened? The working principle is so there will be a supply with a power supply is connected with this one here. Power supply is taken place here. Okay, there will be a power supply and under. So what happened when I'm supplying of a power supply here? So what happened? Electric energy will be converted into a light energy. Okay, electric energy will be converted to a from the power supply. What happened? There will be having a ruby crystal is this ruby crystal. So what happened? There will be having of a so that one there will be a converting of a electric energy into a light energy, then this energy will convert into a heat energy. So what happened? The power supply 100% of a reflect of a mirror can be taken place here. We are converting of a means of a flash lamp both of a, and we are saying of a this end and this end. We are using of a flash and okay, so that whatever the reflecting can be taken place emission. So what happened? There will be a reflecting can be taken place here. So the huge amount of a here take place of a here of a radiations here. So what happened? There will be a reflecting here and there only. So after that, there will be a laser discharge of a tube is they're fixing this one. Okay, means the partially reflected of a mirror is taken place here, so that it will be a passes from this one. If we are not using of a partial, means it will be a reflecting can be taken place here and here only. So there will be having a partially reflecting of a mirror we are keeping here, so that the this of a laser of a beam should pass from this of a partially reflecting of a mirror here, then is a striking on the lens, because we know that there is n number of a reflection can be taken. We have to make it to at a one end. Okay, so there will be we are using of a lens here. That is okay. This is a very important of a lens we are using here lens. So whatever the reflected means of a laser is a discharging from the tube. Okay, from the reflecting of a mirror here partially, it will be striking on the lens and it becomes of a means at a making of a point here. Okay, so there will be a having a focal length is a very important. There will be a distance between of a lens and the workpiece. If you are making of a more distance, so that it will be not striking on the, it will be a strike on the workpiece, but removal of a material is take place of a very difficult. That also we have to take in consideration. Okay. So here what happened? The basic, the very easy method of a removing of excess of material by using of a laser beam machining is here is a simple concept. Here is a, here the power supply is taken place here this end, and the where we are going for the means of a, where we are getting of a laser of a beam of a radiations here through the ruby crystals here, and the solid state we can also go with that one, gaseous state also we can go that one. So what happens, there will be 100% of a reflected of a mirror we are saying here, so that it should not be a move for upward once again. So what happens, there will be a reflecting mirror we are keeping here, and there will be a flash lamp at the both ends, so that it will be reflecting at the, so that it will not passes from that. Only at the downwards we are keeping of a partially reflecting of mirror we are keeping here, so that this from the discharge of a tube, laser discharge from that one, and reflect and partially reflect from the mirror, and this falls on the lens and it makes of a, here at one point. Okay, that's the on the workpiece, and there will be having a removal of material can be taken place here. See, the punch of a is a light of a beam. So here the light of a beam can be carried out here, and it makes of a one end. Okay, all are going to other end. So what happens? There will be a n number of a taken place here. So we are making it converting to by using of a one end, that by using of a this lens here. Okay, this is a very easy concept here. See here, the laser beam is focused on the workpiece here material to remove the unwanted of a material. We know that one. We are removing the excess of material from the workpiece. We can say that the unwanted of a material from the workpiece here by heating. Often in a laser beam is a machining of a metal removal rate, and must be depend upon the wavelength which is used of a, this used in the laser machining here. Means we are going for the machining, that is a MRR, metal removal rate, can be carried out by use here in the workpiece by using this concept here. Okay, laser beam machining. So here, see here, there will be having a work material we can use with the metal with a high hardness and the strength here, soft metals here, ceramics we can go with that one, glass and the glass epoxy we can go with that one, plastic, rubber, cloth and the wood, because already I have said here, see here from the this diagram also I have said of a clearly of a rubber here, plastics here, we can go with the work material that one. Okay, okay, the same manner we are going this one also. Okay. So here the laser we can, just now I said of a, we can go with the laser of a ruby crystal, we can go with the solid state laser, we can go with the, and a gas laser, even different from the, just now I said from the solid gas and the solid state we can go also go that one. So there will be having a, if I say of a, see from the gas laser, if I saying of a electric current, it may be liberated from a gas to generate of a consist of a light. Our concept is a simple thing, we are have to generate of a laser beam. So laser beam can be generated from the simple thing is the electric energy will convert into a light. So it may be of a gaseous state, it may be a solid state, or it may be having a of a examiner from the laser here. This both three things we can use that one. Okay. So as per of a gases of a laser here is a liberate of a gas to generate of a consist of a light here. Some of the most commonly used as a gases, so we know that of a from the argon gas, carbon dioxide, and helium and neon gases. These gases are act as a pumping of a medium into the necessary of a populations of a inversion is a atelier. This is the same thing just now. By using of a, this type of a thing, we can go with the laser here. Okay, light energy can be generated here. Okay, and the solid state, same thing. We can go with that one. Hot material, we can go with the doping of a arms of a lamp, and ruby is one of the frequent use of a hot material. Just not of a ruby crystal, we are using that one. Most of the thing we are going for the ruby crystal for the, so that it will be light is generated is more here. Okay, and the exam means the different from the gas and the solid state. There is a different from both. We are saying this is a examiner of a laser here. So we can use of a machine sometimes known as an ultraviolet of a chemical laser. Okay, we can go with the ultra chemical of a laser. We can also use that one. Very easy way. So here the laser means now we can go with the what are the things if lasers are there. Okay, if I say of a laser of a characteristics, okay, applications and the types of just now of a previous, just now same thing I have just done. Okay, means what are the applications? Now for the types of lasers here. Just now the same thing, where we can go with the cutting and the material, we can go with the drilling, we can go in the same way application as well as the type of laser. So according to the application, we are going for the types of laser here. Same thing, the large or diameter, we can go with the drilling operation, we can go with the same method as the ruby and just now a neodymium we can also say here. So titanium we can go, and aluminum of a garret we can go with that one, which is dot with the neodymium of a we can go with that one. Okay, and large hole of a dependent small holes. That's a different types of means application has for the application types of a laser we can use that one. Okay, so just now if I said of a carbon dioxide with the gases, just now of a gas laser we can go with the cutting process, and the same a plastic of a organ we can go with the non metal of a ceramic, just now of a examiner we can say here. There is a depend upon the just now I said of a see here from this one, see for the gas laser and the solid state and the examiner here. Okay, so according to this one we can go with the see here uh, see from the this one we can go with the hole drilling, cutting and the metal. So we can go with the see here from the gas we can go gas laser, and we can go with the same thing of examiner we can go here, and we can go with the solid state we can go here. That ruby means of a solid state we can go with this. That is the three type of can be carried out here. Okay, very easy. Okay, means laser character we are knowing of this one. Okay, and the laser construction, just now I said of a carbon dioxide of a laser, if I say of a same thing, see here from the carbon dioxide of a laser, if I say of a the gas laser can be axial flow as shown in the figure. We know that one gas flow can be taken place here. Okay, so here with the transfer of a flow and a folded into axial flow here. Okay, axial flow can be taken place here. The power of a carbon dioxide laser typically around the 100 watt. So what happens? This axial flow can be taken place with the volt of a, we are using of a we high voltage can be taken place here. Okay, carbon dioxide typically around of a 100 watt per meter of a tube length, and this makes of a see here. So when we are using of a two of a voltage of a which is a positive anode and the cathode here. So what happens? There will be having a laser can be taken place here. See here from this one the gases can be taken place here. So there will be having a heat is light energy can be converted here. Then it will be passes from here in this way. Okay, it can be taken place from here. Where the lens can be taken. Then there will be having a removing of excess of material from the work. This can be carried out here. This is a optional use of a floor space because high power is a carbon dioxide lasers are made up of a folded of a design. So mainly of this is a take place in a floor space. Okay, take place in a optionally we can use in a floor space here. Okay, so this is a carbon dioxide means we can say this is a we can say the how the carbon dioxide laser can be taken place here. Okay, gases laser can be taken place here. Okay, now coming to the here see here laser construction here. See, this is a very basic solid state of it. Just now I said of it that is a Rubik. Okay, this is a Rubik crystal is a taken place here. We can say that from the same diagram. Once again, I'm repeating here. This is the carbon. After the carbon dioxide, we can go with the gases. We can go with the solid state of a laser here. Same thing, same procedure of a see here. See, this one of a same of a this is a solid state of a same thing. We are going here the same concept of a here also. From the solid state here also the same thing. Okay, we are going for the power supply here, power supply where the electrical energy will convert into a light energy due to this of a and lamp we are keeping here so that it is reflecting, and here total reflection of 100% reflecting can be here is a we are saying of a partially can be reflected means of a discharge of a tube. This will be a radiations can be taken place here and the falls on the lens here. After that it will be a see here. From that one, it will be false on the surface. And removal of excess of material can be carried out here by using of a solid state here. Okay. Now coming to the laser of a construction, we are very well known of this one. Okay. This one is a last one, examiner of a laser here of a neodymium of a we can say laser here. Same thing of a same crystal we can use here. Same type of a crystal also we can use here. See here of a laser is a pumped of a using of a flash tube, and just now I said of a ultra chemical of a laser we can use here. of a flash tube can be a helical, has a shown in of this one of a here, okay, and they can be flat of a laser of a same thing, okay. From this one of a flash tube and a housing can be crystal can be carried out here, and from the figure we can say of a through the helical of a flash tube of a this is a helical of a flash tube, okay, and they are difficult to maintain, but very difficult by using of this of a this type of a laser. Okay? There are different types. That is, I said of a they will be having a different types of a lasers we can say here. That is a gases we can say that is a solid state I said, or and we can go with the example of a laser. We can use a three different type of a laser. We can use that one in a laser beam of a machining process here. And there is a cutting depth we can say of a that's a very important point here. The cutting depth of a laser is a directly proportional to the whatever the means of a by using of a means of a power. So it will be divided by the power here and the laser beam by the product of a cutting velocity here. So there is a formula T is directly proportional to the P by B to D means depth of a cut and the laser beam of a power here. What is the notation we can say here? So the depth of a cut is directly proportional to the laser beam of a power and which is divided by just now instead of a laser beam of a spot of a diameter here. Here the cutting depth is place of a major here that is we are saying that is a depend upon the focal length. How much length we have to go means what is the distance between from the lens to the yeah. So that is the cutting depth can be measured here. Okay. So the depth of cut is also influenced by the workpiece of a material that we are using of a brittle material here. The material of it reflected of a density, specific heat, and that's also a melting point of a temperature. All contributed to a laser of ability to cut the workpiece here. Okay, these are the see here. This is the cutting depth, and the process is very easy way here. We can go with the here. See here how the process can be carried out here means simple thing. Just now I said of electric energy will convert into a light energy, and this energy will convert means light energy. Then it's converted into a heat energy. Okay, that is the reason we are saying of a light amplification of simulated emission radiation will be generated from the laser. Then of a beam with the machining of a material removal can be carried out. The same thing can be here. See means due to what happened if I'm saying here. See here, if a lasers are taking place here means electrons. So what happened? There will be a levels of a here heating can be taken place 1, 2, 3, 4 here. So what happened? We are electrons. What happened? Heating can be taken. So when it comes into a means of a stable condition, then it will light will be generated here. In the same manner, see here, due to this of electrons here, the negative charge of electrons are rotated around the positive charge nucleus in the specified of means of a orbital path based on the parameters like atoms, electrons, electron structures, and the presence of a electromagnetic. This all things means we know that one. From the laser beam, we are getting of a electric energy can be converted. Means they will be having the atoms, electrons, electron structures. The means this all presence of a due to of a electromagnetic of a fields here. Okay, which can convert it into a light energy here. So because what happens, this is the reason the all electrons occupies the lower potential energy. So that is the reason the ground level of electrons absorb some of the energy to simulate the high stage. So that is the reason if I going to the see from low level to a high level, it will be electrons can be passed from a low level to the high level when we want to get in a stable condition. So they will be having a light will be a form here. Okay. So here the photon are external of a source here. The electrons are moving from the lower to the higher energy. Okay, this is from a moving from a lower to a higher energy. The basic concept. Okay, here are very known of this one, electrons and the photons regarding that one. So here we have process here. Another process means continuation of this process here. This is a when this electron reaches the high energy means of a low energy to high energy. When it is the electrons is reaches to high energy, at an instant we observe that an unstable band means of it will be comes into a stable here. So what happened? We observe the unstable band of the energy by releasing this photon. What happened when we are releasing this one photons due to this electron? Okay, photon. What happened within a short time it reaches the ground level here. So due to this, when this comes into a stable, when immediately what happens? This comes down to the unstable. We have seen that one. Okay, due to this of a photon, what happened? there will be a, so process is known as spontaneous emission, we are saying here. Increasing means lower level to the higher energy level, it is reaching to the, so due to this electron, the photon, what happened? When it becomes of unstable, means it's falling on that one. That is the reason we are saying that is a emission here. Okay. This existing of a photons and emitted photons have the same frequency here. Okay, the photon and the this what happened, existing photon and emitting photon, both are at the same frequency, then only it will be taken place here. Okay. In the same manner, energy state changes. See here, this is a very important point here. Energy state changes the positions of electrons into a metastable of energy here, as well as in a material of electrons are pumped to a high metastable here compared to the atom presence in the ground state here. That phenomena we are saying, that is a population inversion, that is there. Simple concept here. Okay. So here that can be taken place here. Means here the ground level of a means of a form of rush. Means we are saying of a photon here. So what are electrons here? That is a move from the photon. Okay. So appropriately the energy and the frequency is called as, we are saying, that is a simulator of emission here. In the same manner we are saying this is a lower, means we are saying the electrons moves from the lower energy state and comes to the original position. That is the stable energy we are saying. Okay. When I am saying of a lower energy of a state and comes to original position, that is a stable energy. So what happens? Stable of a band, we can say, comes into order. This emit photons of a reaction comes having a some longitudinal of a phase here. Just now I said of it. So here we are saying a proportion of a phase available of a current of a laser beam is created in this way. When this will be taken place here, automatically what happens? The light will be a gets of a emission can be carried out here after this one. Then it falls on the lens to the workpiece. This is the how the concept can be taken place here. Okay. Now coming to the here, see here advantages. Since the rays of a laser beams are monochromatic, we are very well known that is a laser beams are monochromatic and a parallel it will be focused on a very small diameter. You know that one, okay? Monochromatically is coming out, okay? Layer by layer. So what happened? And parallel it is a focus on a very small of a diameter here. So here produce of energy it may be a 100 micro of a meter here. So milliwatt of a milli 100 of a milliwatt of energy from a square of a millimeter of a area here. That is a one type of advantage here, because we are having a different type means of it layer by layer. So what happened? This focus a very small diameter here. So when it is becomes of a here of a monochromatic of it can take place of it due to of a focus here. Convex. So what happens? There will be a force of it. So point can be taken. So it is when force on the workpiece. So high energy will be generated here, and it can remove the excess of material from the workpiece. That's the concept we know. That is the advantage of this one. And suited to a making accurate of a place, means we can make of a accurate of a hole. We know that one. By remove it, because with the laser we know with the by using of a computer numerical control of a, but everything is automatically here. We no need to go this one. Okay. So it is very advantage that it will whatever the accurate hole we can go with the by using of a laser, because we are converting, that is very important, because we are converting of electric energy to light energy and light energy to a heat energy. So that is a false on take place here, and accurate energy, accurate holes can be taken, accurate of a removal of a material can be taken place here. So here the very traditional of a cutting method may fall short here, and the cost of material laser is moderately low due to the low rate of a wear. We know that when a material tear and the wear can be take place very less here, and there is a no physical contact between the tool and the workpiece, because we are there is a no tool contact with it, because Rubik is act as a tool, but there is a no tool is directly contact on the workpiece here. But due to the high heat of a laser, it's falling on the workpiece here and remove of excess of material from the workpiece by using of a laser beam of machining process here. So there is a no physical contact. We know that there is a reason we are saying that is a non-convection of a machining process. We are saying here the modern machining process we are also saying here, and the machining provided by a laser beam is high precision, and most of this process do not require of additional finishing, because it is a very accurate here. Okay. So no need for the additional finishing can be carried out by using of it. That is the beauty of this laser beam machining here. Okay. And the laser beam can be paired with the glasses to help the cutting process be more efficient and help minimize oxidization with laser which can also protect from the atmosphere also. Okay, and free from the melted and the vaporization of material. Okay, what type of advantage here? Disadvantage, if I say here initial cost, because the laser, that is a very harmful. If we can't go directly, we can't touch that one. So this is also a very laser is a beam is a more initially is a very cost here, and compulsory we require one skilled operator is required here. We can't go directly blindly. So here the many accessory, and that is the machining of a process, as a, most of the accessories are important as the laser beam itself startup cost of it. Machining. That the cost setup cost is very very high here, and handling and maintaining of a machining. That is the laser, so it is a very dangerous here. So that is a handling and maintaining is also a machine of a requires high kind of individually we are on that one. Okay, and the laser beam is a compared technically, and service from any expert may be required. Just now, if a skilled operator can be required here. That's also one disadvantage here. And laser beam machining is comes a lot of energy here. That is the reason we are using for the laser means of a gas, solid state, and examine. So we are using a lot of energy will be generated here. That is the reason also one type of it means harmful to the one body also. So due to that one only we can machining process can be carried out here. And depth cut are difficult with the workpiece with a high melting point. If high melting point take place, depth can be take place is very very difficult. Okay, and usually cause as a taper and just become. And applications, we know that the welding, CADing, marking, surface treatment, drilling, cutting, all other process means applications, shipbuilding, aerospace, steel, and electronic. Now the medical industries, we know that a laser of a retina, we are going for the laser operation. We are saying cutting operation can be carried out by using of a, that is a laser beam of a machining concept only. This is also not this, okay, laser beam of a machining only. We are going for the retina surgeries also. That is a very important. Laser. We are saying that uh, laser of a operation we update here. That is the concept from the laser only. That's concept of a means eye operations and some other surgeries are also carried out by using of this sort type of a laser beam of a machining process of a concept only here. That is the reason medical industries so complex to complex parts. We don't know what is the important of our human body. So how much delicate it is. So we are going for the relic. So that is the reason it is in medical is very 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 useful of this concept here. Okay, and here the drilling cutting with the laser is a advantageous here, and because especially this is useful for the brittle material, there is a no way can be taken place on the cutting tool here, and no contact of a cause of a damage here. Okay, there is a, and but only the cost is very high. That's only the one problem here. Remaining are, and experience and medic experience for a person skilled operator is required here, especially here. And here the we can go with the especially for the, if I says here, and made of a very easier to remove here, reducing the cost of production and the wear of a tool while of increasing the tool life here. We go with that. Okay, so here, thank you and have a nice day.